Welcome to Rges Pre-Algebra. This is Lesson 21B, and your section is 5.1. We're starting a short unit now on scientific notation. Now, there's two aspects to scientific notation. There's the actual number itself, and there is the 10 to the exponent. So it's composed of two parts. Now, a scientific notation is a way to write very large numbers and very small numbers so that they're easier to read. Because when you get to, let's say you have 573 with 10 zeros after it, it becomes difficult for us to read. So first off, we're going to talk about the number part. This is for very large and very small numbers. So let me give you a very large number. Okay, these are three very large numbers. Now, first you want to identify the number part. That would be the non-zero number part. That would be all of this. Even though it has a zero in between, that's okay. We just don't want trailing zeros. Here it would be all of this, and here it would be all of this. Now we're going to write these with just one decimal point. So the first one, let's go back to a black, is going to be written as 5.3708. And then we're going to multiply it by 10 to a power times 10 to a certain power. We'll talk about that in a minute. The next one, I want the decimal point after the first digit, 2.001 times 10 to a certain power. And the third one, we're going to write 4.00006 times 10 to a certain power. Okay, so we identify the number part by taking off all the trailing zeros or zeros in front, which of course with a whole number you wouldn't, if you're going to make real large numbers, you wouldn't have a zero in front. Okay. So we're going to just write this part, and we're always putting the decimal point right after the first number. So this is actually easier to read than this. So that's why we're doing this, okay? Because it's easier to see the number part. Now, what would I do to write 10 to the something power? Well, notice, first off, there's a couple things you need to know. 10 to a power, let's say if I have 2 to the third power. That means 2 times 2 times 2. Right? So 10 to the first power is just 10. 1 times it. But if 10 to the squared power is 10 times 10, or 100. Well, notice how many zeros, when I have 10 to the first power, that equals 10. How many zeros are there? Well, just 1. When I have 10 to the second power, how many zeros are there? 2. So the exponent is going to represent how many zeros? In this case, the trailing zeros, okay? So we have moved this point, well, it represents more than that, but we have moved this decimal in the first example. We didn't write the decimal point, but the decimal's right there, right at the end of the number. So how many places did I move it over to move it to this? Well, I moved it over that many places. 3, 6, 9, 10, 11, 12, 13 places. You see what we're doing? In the next one, I've moved it from there to there, 3, 6 places. And in the next one, I've moved it from here to here. So I've moved it 3, 6, 9 places. Okay. So this format represents scientific notation, and it's another way to write a very large number. So that's how to go from the very large number to the scientific notation. Let me do it one more time for you. 378400000. My decimal point right now is there, whether I write it or not, because this is a very large number. I want to only write this part as my number, 3.784 times 10 to a certain power. How many places? I moved my decimal over 1, 2, 3, 4, 5, 6, 7, 8 places. Okay. So that's how to go from a very large number to a scientific notation. Now let's discuss how we would go backwards. Let's say I have 7.034 times 10 to the 5th. So I would start with 7034. My decimal point is here, and I want to push it this way 5 places. 1, 2, 3, 4, 5. So this converts to this. Let's do another one. If I have 3.0002 times 10 to the 9th, okay, I'm going to write this part just like it is, 3.0002 without the decimal point, but I'm remembering where the decimal point was, just after the first one. Now I want to move to the right 9 places because of the exponent. So I've moved already to 4 to get to the end of my 2, then 5, 6, 7, 8, 9. Putting in your commas, you're going to get a very large number. Okay, 100,000 million, 3,200,000. So that's how you do it. You move both directions. You can study it again in their examples, and I think the only thing that's kind of confusing for students is when they have something like this, when they're moving from scientific notation to a large number. Remember, if the exponent is positive, it's going to be a larger number. And depending on how many, what the value of my exponent is going to show how large a number. A larger number than the part on the left. Okay, so give yourself a try with that, and we'll discuss any questions you might have when you get back to class.